Okay, so let me. Yeah, so I mean, I'll just draw. So you, Devin, keep thinking. Tobias, keep thinking.
Yeah, I think I'm thinking and building up on what Devan said. It feels like if you have a way to track all the nodes seen at every level, maybe you don't have to, but as long as you can keep track of the level and the node seen, then you know the leftmost.
Mm-hmm. I mean, so you're saying that you build a hash map and the key is the level distance,
Yeah.
and this is your array.
Yes.
And so you have h of 0. Let's say this is your root. Wait. So you're saying h0 will be your root. Your h1 will be all the nodes. Like this will be 2 and 3.
Yeah, but you'd have to visit them in order.
Yeah. So 4. So as you're seeing. Okay. So how do you do that? And you're saying your h of 3 is your 7, and you're saying that you note the highest.
Yeah, that's where breadth first search kind of applies, right? You're visiting every level,
Right.
right? Yeah. So you would get it in order that way, right?
Yeah. So for 1, you'd visit 1, and then your next visits would be 2 and 3, and then next would be 4, 5, and 6, and then 7.
And then
So
if
so
you have
for
3, you return the first element. That's what you're saying. I mean,
yeah,
if this had 7, 8, 8, you'll return 7.
right.
So Tobias, you're also same.
Oh yes.
Same idea, right? Arya, what
Yeah.
about
I
you?
have a question here. Ankur,
VT, Vishal. Yeah.
do we need a full-blown version of breakfast search here?
Meaning what?
So how do you find the deepest node? You're gonna need to look through the entire tree, don't you?
Right. But what if we do our traditional traversal, like maybe pre-order traversal, and when we hit a root node, we
No,
add
so
it
we are
to
not.
a
We are
queue.
trying to cover BFS. Trying to solve this using BFS. That is what I want to start with.
Okay.
Maybe there might be other approaches like
Okay.
BFS or something other, but here we are doing BFS. Okay, Vishal?
Got it.
Yeah.
Yeah,
So
understood.
I mean, later on we will go with your different approach also, but right now. And Arya, what about you? Same thing?
Yes, I guess. Yeah, that's correct. Because if you go through the level, it's kind of BFS, of course, and then each level we are going through with the node, as you mentioned. My question is how I'm gonna do that by label order. Am I right? It's just a simple label order. I can apply it here. Am I right?
Okay.
Yeah, and like I have a hash map as is or something that I can save it each label and there in a list of node in there, something like that.
Okay. So what is the time complexity, Devin?
Time complexity is gonna be
Basically number of nodes.
number of nodes, right? O of H.
Yes.
Not H, O of number of nodes. And the space complexity is going to be
Again, number of nodes because you're storing everything in a hash map.
Yeah.
Right? So I'm not asking Sue yet. Okay, Sue. So you're not happy with the answer?
Yeah, I just coded it, Ankur, in time complexity order of n, space complexity order of 1.
No. Then you then. Okay,
Yeah,
so
I'm not saying anything. Yeah.
yeah. So Tobias, Devin, and Arya and Anil, I don't want you to use space.
Okay, so as we traverse to a larger level or next level, we don't care about the previous level.
But you still need to keep track of the leftmost value. That's the weird part. And if you have 3 nodes all at the same level, right? The one on the leftmost side is what matters.
Okay.
So try it.
Ankur,
Yeah,
I'm
yeah.
confused. why you say that we cannot use that?
So the
Like,
first one, isn't it that the first one we see always the leftmost one
yes.
by the nature of adding it to a queue or whatever? So
So why did you ask, put your answer, Sue? Okay, no one look. Okay. I think Sue, I mean, she wanted to send me personally.
Yeah, I wanted to send you only.
Okay.
Sorry, I'm
Yeah.
sorry. My bad. I don't.
Yeah, so Tabaya, so go ahead. So I mean, your thought, whatever your thought was, do that.
yeah, my thought was that if as we're doing BFS, by the nature of queue, the first node we see is usually the leftmost at each level.
Hmm.
So that way we don't need to keep track.
Actually, if you do an
Hmm. Yeah, they were.
in order or post order traversal, right? Pre order traversal, right? You're guaranteed to always go down the left first, right? So if you keep track of your height and if you keep track of your value found and the value height.
So Devin, so I know you're going with that. I think Vishal's approach. Solve this in BFS. No pre-order, BFS in order. Not in order, actually BFS.
Okay.
Yeah, because I want you to see BFS. I mean, I want you to visualize so that you understand what breadth first search is, so that I can take you to the next level and then the next level. We're not trying to solve this problem, but we're trying to learn what BFS is and how you can use BFS to solve C patterns. Right? So whatever Tobias said, you agree with that, Steven? So he said you see each level, and the first node at each level is the leftmost.
Yeah, that's true.
Yeah.
But then you're right now we need to keep track of. Actually, we don't need to keep track of it in a hash map at all.
Mm-hmm.
Every time we get a list of the next node we have to visit, the first one we see is the leftmost one.
Yes. Right.
Because if we go to 1, can you go back to the scroll up? If we go to 1, we know we have to visit 2 and 3, and we know the leftmost one is already 2 by default, right? Now, if we look at 2 and 3, we know we have to visit 4, 5, and 6. So we know the leftmost one is 4, 5, and 6. If there's another level beneath that, then the answer is 7. So you don't need to keep the hash map at all. You just need to keep track of which node you have to visit next. And then in your loop, whenever you're putting together the node you have to visit after that, the first one you see is always going to be the answer for that level.
Yeah. So basically, you initialize a variable called left equal to none, and every time you you go to the next level, you always put left, and then you put the first element of your level into that, and at the end you return left. That will return your left. Say, Sue, same technique, right?
Sorry, I didn't follow Ankur.
I mean, you traverse each level. You put your first element on that level into your left variable, and at the end you return left.
Yeah, so the space I realized is not actually order of 1, but the number of elements in a level, like in the queue.
I mean,
yeah.
Eventually your queue is going to get empty, right? You're going to do pop and everything.
Once you finish a level, your queue is empty. No, every time you finish a level, your queue is not empty because it can contain the list of all the nodes you have to visit next.
That is still your space.
No, but at the end you don't have any space, right?
Yeah,
right. Once you go to the last level, your queue emptied out.
Yeah, I mean, at the end you have only your last level of the elements left.
Yeah. That way, in the order of 1. That is how I coded it as well.
Okay, yeah, I mean, then you can say your space complexity is like the level of the last level, the number of nodes in the last
the space
level.
complexity is going to be the the worst case is going to be
But-
the level that has the most number of nodes.
Right,
no,
not
but
class.
wait, Sue, you don't even have to. I mean, you don't even have to. Let's say you don't even have to enter your last. So if it is, let's say you find out the height of the tree, the maximum height of the tree, right? And when you go to the last level, if you know the height, you don't even have to enter your last nodes, right? You just return the first left. In that way, you don't even have to enter the last level of the nodes in the queue.
Wait,
How
are
do
you
we
suggesting
know?
we find the height first?
No, we are. How do we know?
No,
we
no,
are
as we're
done
going through,
here?
right?
As we are.
Yeah, but as we are going through, how do we know
No,
we've
we still
reached the
need to go
max
to
height?
the last level to figure out if there are any nodes after it.
Right,
Right.
right.
No. What I'm saying is, this one, right? This tree. Wait, are you guys seeing this chat also, participants?
No,
No.
I'm
Okay.
just saying this.
What I'm
So
saying
just
is,
when we see 1, right?
Hmm.
The queue is going to have 2 and 3.
Hmm.
Now, once we process the queue for 2 and 3, the queue is going to get 4, 5, and 6, right?
Hmm.
When we process the queue for 4, 5, and 6, it's going to get 7.
Hmm.
Oh, in this scenario, because the queue had 1 element left, we don't have to go any deeper. But if the queue had more than 1 element, we need to go deeper.
Yes, but if this has 8, 9, and many, yeah.
No,
so
actually, we still need to go to 7 because we don't know if there's anything beneath it.
yeah. Yes, I mean, and you'll also have to process 9. You'll also have to process 8, 10, like 8 and 9.
Yeah,
That's what
because
you're
we
saying, so right?
don't know if there are no children to 7, we don't know if the next leftmost is coming from
Yeah.
like
So
the rightmost node. So we have to keep adding them to the queue, and the space complexity will be the maximum nodes that can be present in a level.
no, but I'm saying is, I mean, you're saying is at the end your queue will have all the nodes. I mean, nodes after your leftmost element in your queue.
But yeah, even though you pop out, Uncle, I think in space, when mentioning space complexity, you have to mention how much space you have.
No, but
used.
what I'm saying is how much space of the last level of all the elements.
Of the size of the queue that you're using when running your program, at maximum, how much size the queue
Oh,
is.
okay.
Yeah, it's worst case of h squared. No,
Worst
two-
case of the
2 to the h.
No, that's not. Worst case of the maximum number of nodes that can be present in a level.
Yeah, so that's 2 to
Yeah,
the
2
h,
to the
isn't
power
it?
h.
2 h
I
to
mean, if
the
h is
power
your
of the
height, if height is h, the last level will have maximum 2 to the power h element.
Right.
So
So
that
in this
is
case, 1.
in this example, right? 1, 2, 3, 4, 5, 6,
Hmm.
or say 5 has only node 7. After none of them have children, so maximum nodes in the level, even though there
No,
are.
but what's the worst case? The worst case is that entire level is full, right?
Wait, Sue was saying something. Wait, Sue, complete the
Oh, okay.
sentence. What are you saying?
So I don't think you can represent as 2 parts anything.
No.
Why?
So
What's the worst case?
if
What's
height
the
height is 4, right?
what's
Okay.
the maximum number of nodes you could get at the last level?
If height is like 1, 2, 3, if let's say height is 3,
Mhm.
1, 2, 3. If height is 3, 1, 2, you'll have like, let's say this 8, 1, 2, 3, 4, 5, 6, 7. How many nodes can you have here?
Got it.
That will be what? 5, 6.
It's a binary tree, so it's 2 raised to the
4, right? 16.
height.
Not 5. 1, 2, 3, 4. Like this will have 8. So 2 to the power 3. Right?
Yeah.
No, so and what I am saying is, if you actually considered the whole height first, like evaluated the height first. No, if the interview says, okay, remove that first also, find out the height first, and as you're traversing, right, you also know that okay, you've landed up here, you figured out 7, return 7. You don't and pop all this out. I mean, the point was okay, we got BFS, we understood what BFS is, right? Like you're able to understand what BFS is, right, everyone?
Yeah.
Yeah, that was the point. Like after that, you keep solving whatever the interview says, you do whatever. But point was to understand what BFS is, right? So everyone got right, Arya? I mean, you use
Yes.
a hash map and then you use BFS. You're basically basically you use breadth first search when you want to do something on the same level.
Right. So we
Yes.
can just use depth first search digits and keep track of the height, and then
Mm.
whatever one we find. Well, the first one we find at a given height is going to be the leftmost one if we use depth first search, right?
Weird. So I think if you start from 1,
If you go to
you
for depth
keep
first
going
search,
down.
you're going to go to 1. You're going to go to 2. You're going to go to 4. You're going to go to 5, right?
No, there's not.
So-
Let's suppose there's nothing here. So basically,
Okay. Why don't you scroll down a bit and draw a new one? Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah. Can you go back to the app? Yeah. So the way depth first search would work is to go to 1, then 2, then 4. It would keep 4 as the maximum value right now. Then it backtrack up. It goes to 3, it goes to 5, it goes to 7 because 7 is deeper than 4. It keeps that. It backtracks up from 3, it goes to 6. And
But
because
how
6,
Yeah, how do you know, Devin, that the height of this particular branch is more than the previous branch for us to override? So
why can't you keep track of the height? Why can't you keep track of the current height, the maximum
things-
height, and the maximum value? It's just variables you're passing in, right? So at each loop, you pass in what node you're looking at, right? Your current depth, your max value, and your max depth.
so maybe we don't talk about DFS here. Like I want like otherwise we'll keep going into DFS then. I just
Okay.
wanted to cover BFS. Like I mean maybe later. What should I do? So Vishal, do you want to? You had some technique, right? You just mentioned. Was it the same thing as what Devin is suggesting? You said pre-order traversal or something.
Yeah, my technique was basically to go pre-order traversal, and when you reach the leaf node, you just add it to the queue. But
Well, how do you know the height then?
That won't solve the problem.
Oh,
Height,
okay.
you don't need height, right?
Why? If you add it to a queue, right?
Right.
So let's say in this example.
See,
you're
No,
doing-
Devin.
you're
See,
right.
Devin.
You're right.
Yeah, I mean, see, Devin. I mean, if you're working, I mean, if you're don't try to. I mean, if you can solve this using BFS, go with BFS. BFS is a very simple technique, but if you use DFS, right, you'll get all confused and everything.
Okay.
So that is one, but yeah, go ahead and try to like. Even I'm trying to think how to
Even
do
Devin is
BFS.
right. The edge count is needed because when you're at 4 and then so even though I add it, the only way I can knock off 4 if I have an edge count which is greater than 4. Like when I hit 4, my edge count is still 2, but when I hit 7, my edge count is 3. Correct?
Right.
So that information is needed. Devin is right there. Right.
And what if we calculate the height before itself? Like we do 2 processing, right? First processing, we calculate the height.
Right.
So that will be, I mean, that will not take any space, right? But after that, we do a DFS as Devin is suggesting, and as soon as we hit something which has a height 6 or say height, we return that.
You don't even need to calculate the height. You just keep track of the height while you're doing the search.
No, but in that case, you'll still have to figure out what if you calculate this and you have, I mean, you'll keep. Let's say you found this, right? And but you'll still have to process the other nodes as well.
Right. You have to
Figure out if
process,
there's something.
no matter what, you have to process all the nodes.
Yeah, but if you calculate the height first itself, you get this and you return.
Yeah. Okay,
I mean,
that
that
works
is-
also.
this is something,
Yeah,
I mean-
that works.
Yes.
I'm
But
just combining it to, you're doing it separately.
yeah,
So
there are many ways to like do right,
Right.
but I would do this in BFS because this is like the simplest thing. So I would like to show one more question. Wait,
But is that the proper way of doing it? That's what the point I wanted to bring up.
find. Wait, what was the question? Was it this? Not this. Don't even this one, right? No. So let's. What was the question? Bottom leftmost tree, right? Find bottom left tree value. This one, right? There's no solution here. Let's see. Right to left BFS.
Wait, don't pull it up. Let's at least see what the question is.
No, this is okay. Wait. I mean, BFS you can just do it. I mean, the point is to practice. Okay, there is something called BFS. Do
Right.
that way. And using BFS, there's one more question is. Okay, this was the question we were doing. Okay, binary tree, right side view.
Given the root of binary.
These are all high frequently asked questions.
See ordered from top to bottom.
Wait, Tobias,
What if
you're
you get like
understanding? Wait. Only you're speaking. So let's say, Tobias, are you understanding anything? I mean, or do you want us to code it?
Oh, the previous one I understand. I'm just reading the new question.
Okay, then try this one. I think Arya, you not speaking. Do you want to solve this?
No, I'm still like thinking about it. So yeah.
Then go ahead. Then if you're thinking, then do this. Given the root of the binary tree, imagine yourself standing on the right side of it. Return the
Yeah.
values of the nodes you can see ordered from top to bottom. So I'll just draw this. 1, 2.
Can
5.
you scroll down to example 3? Somebody they did it.
I think this one
example
is
2.
enough, right? So you return 1, you return 3, and you return.
Yeah,
4.
but if you don't have 4, the answer would be 1, 3, 5.
Which one? 1, 3, 4.
No,
Wait.
if you
Now
remove-
No. Okay. Tell me. I mean, I understood the question. So now clarifying questions. Yeah.
Yeah, if I remove
Yeah.
4, right? The answer would be 1, 3, 5.
Yes.
right? Okay.
Yes.
All right.
So if you had 1, 2, 3, 4, your answer will be 1, 2,
2,
3, and
3,
4.
4. Right.
And if you had another 4 here, it will be still the same.
Right.
Yeah. So basically, you're looking from here. So what are you going to see for?
Right. 1, 2, 3, 4.
Yeah. What happened? No one got it.
No. For breadth first search, just
Yeah. So we are covering breadth first search only. We're not doing DFS.
yeah. For
anything.
breadth first search, as you process each level, the last element you see is on a level, the element you'll see on the right side.
Is it so like when we are doing BFS like a label order, instead of previously we were always saving the leftmost node in each level, like you know.
Okay, right now, so
Yes.
for example, at level 1, you see 1, right?
Yes,
That's the only element at that level.
exactly.
So you're
Mhm.
guaranteed to see it.
Yes.
At level 2, can you scroll back up to the original picture? At level 2, you see 2 and 3, right?
Yes.
So if you keep an array, 3 is the last element in that array, right?
Exactly. Last.
So
Yeah.
you're gonna see it. At the
So
next
let's-
level,
yeah.
you're gonna see 5 and 4, right?
And you would keep it 4 as the
Right.
last
Basically,
element.
for each level, you're grabbing the last element.
Exactly. That's what I'm thinking. Yeah.
So I just quote this when you're explaining. So I'll just show there are like multiple ways to do this. Sorry, not none. This will be empty. Right?
Yeah.
And let's say you put in, I mean, there are like 2 ways to do this. I'll show Python way, like in Python also, and then Sue also came up with one more way. So we'll do that also. It's better to know both the ways.
Okay.
And both have their own usages. So it's like, it's better if you know both of these things, right?
Okay.
Right. So one of the ways that I think how Sue does this is while you, right? And then what she does is what she does is she gets I equal to 0. She calculates the length of the queue, right? And while I is less than length of the queue. So this, and so this, she's going to actually pop out these many
Yeah.
times,
Okay. So
right? So
when you
basically she's
pop
only
it, it's gonna
popping
get
out.
the right.
Yeah, she's only popping out the number of times from the previous level, right? If there are two elements in that, let's say this is 1 and this is 2 and this is 3, she's only making sure she's popping out only 2 times. Even though if this has 4 and this has 5, the queue is also going to have this one, right? When this has been processed, but she's only popping out 2 times basically.
Right.
Right, so it's not even. Okay, and if node dot left, queue dot append node dot left,
Right.
and similarly if
Node dot right. Q dot append. Node dot right.
right, this one, and since now this node, right, this is going to be the for this iteration, right, this current iteration, this is going to be the rightmost node.
Wait. Hold on. If you do 1, right, and root is gonna be 1, right?
Mhm.
So that's gonna pop. If the node length is 0, that's your rightmost node.
Mhm.
Okay.
No, so this level, right, this is going to be the per level, this is going to be 1 level, each level iteration.
Right. That level, but the
Mhm.
how do you determine if it's the rightmost node?
The last node that you have processed is going to be a rightmost, right?
Yeah.
So
Okay.
you first
that's
process
basically
2.
yeah. Okay.
So first you process 2, then you process 3. So 3 is going to be the last node that is going to be evicted out of this iteration. So you put it into your result. So let's say your node here, this is none.
Oh, okay.
Right?
Then, yeah. Now it makes sense. Okay. I was wondering node is scope to that while loop. What
Yeah,
are you
no,
gonna
no.
do with
I
it?
mean, so result dot append
Node.
none, not node dot val,
Yeah. Okay.
right?
Yeah.
And
Okay.
at the end you just return result.
Yeah, that makes sense then.
Everyone understood this one?
Yeah.
I mean, this is
Yes.
like the one of the ways to do that, and this is something that I learned from Sue. And now also that once he coded, exactly the same thing.
Yeah, it's basically best for search. You're queuing up every level, and then
Yes,
the while
and
loop is scope to how long that.
yeah, and there is
that
one
level
more.
is.
Wait. And there is one more way to do this.
Okay.
So I'll just show this one, right? So I mean, both are fine. I mean, some people also add in a none, but I think instead of adding a none, I think the way suited actually makes most easily to work around this. Otherwise, it's like you'll have to write a lot of if conditions. So while queue, right? And let's say you create an empty array, and you're going to put in all the elements here,
Okay.
right? So for node in queue,
Right.
I mean, basically you, if node
You're-
dot left, you append to temp,
Right. If node dot right, you
right?
append
You append
temp.
to, right?
And then after that for loop, the
so
you
now, I
grab
mean,
the last element, right?
yeah, and here you just append result dot append, whatever is there in your temp, not in your temp, actually in your queue.
Temp dot last.
No, queue dot last. I mean, this is your first level, right? You still need your first level.
Oh yeah. Okay. Yeah.
So
Okay,
and you're changing your queue. I mean, you just change it to the next level, and then at the end you return result.
Yeah. Okay.
That's all. Is
Yeah,
it
that's
clear?
a bit uglier. The first one is cleaner.
But I mean, if you see this one, this is actually. I mean, so this is not bad. I mean, this is. I mean, most of the implementations they do it this way only, because this way you're at each point, right? You're also getting in your each level also, and let's say, I mean, right, as you're processing, you're getting your each new level. I mean, there are two ways. It depends how you want to code this up, but it's
Yeah.
better to know both the ways. Both have their own usages.
Okay.
Right. So is the both approach clear to everyone?
Yeah.
Yeah,
Can you scroll up?
and-
Can you scroll up to the earlier one?
In
Yeah,
the first
second
one,
one.
you're maintaining the same queue, but you're limiting your while loop to how many nodes are in a level, right? So your queue will get bigger and bigger, right? But in the case of the first level, you're only looping once. In the case of the second level, at least in the example, you're looping twice, right?
Mhm.
But you're still appending to the end of the queue.
And no, you're popping also. See?
Sorry, yeah, you're popping and appending. But in the second example, you're resetting your queue every loop.
Yeah. I mean, so eventually, yeah. I mean, both the cases, if your garbage collector is going to do the same thing, you don't have any reference to the values that are there in the queue. But basically, you throw it out, right? You're changing the pointer, so it's going to be sitting in the in the memory for garbage collecting. Same thing will happen in the both case anyway. But it's
the
good.
first one's a bit more memory efficient than the second one.
But it doesn't. I don't think it will matter to the interview.
No, it won't.
Yeah. But yeah, so someone was asking, Arya, to buy a second approach.
Yes, Ankur.
Yeah.
Yeah, Tobias, you had a question about the second approach?
No, actually, I wanted to go back to the first approach to
Hmm.
confirm, but I think I saw what I need to see.
I think, wait, I'll just put this approach. Okay, I think I'll send you Sue's implementation as well.
So essentially, when we go to the root node, right, the queue is only going to have root. Okay, so that while I is less than length of queue.
I think we should go with an example. I think, right, Tobias? You want to do that?
Yeah, draw a new node, draw a new tree, and then we can.
No. So Tobias, do you want to draw me? Do you want me to draw the tree? Or is it-
I'm good with Sue's solution. Maybe the second one you can draw it. The second one I didn't understand what Q of minus one was.
No.
That's the
Wait,
end of the
this one?
queue.
No. So basically,
Oh, okay.
yeah. So this is the last element. So initially, so let's say this is your 2, this is your 3, and this is your 4. Initially, your queue is going to have this one,
Yeah.
right?
Uh-huh.
And so I go I go through while loop. There's only one element. I create a new array called temp, and I add in 2 and 3. Okay, nodes, and then so this is my new level now. Now I just change the pointer. Now my queue is going to point to this one now. So next time when I do, my queue is going to have only 2 elements, and my temp is going to be empty. So now temp will have only 4 now, based on the processing of this level. So now queue will be updated to this one, right? So queue represents each level now. Got it? So first time when I come, all I'm doing is I need the rightmost variable, right? So first I have 1 in my queue, then I have 2 and 3, and then I have 4. So each time I come, I pick this one, I pick this, I pick this. So I get my rightmost value.
Okay.
So it's very important. Like even before we go into 2D arrays for BFS, this is a very important thing to understand. What is like the ways to even code BFS. Both these techniques are going to be useful, because eventually in BFS you are going to do queue working around queue and everything. Okay.
So in the second case, you are maintaining 2 spaces, one for the level and the second for all the
next
nodes
level.
I'm going to. Yeah, okay.
I mean, that's what, like current level, next level, current level, next level.
Right.
And as I'm going, and every time I'm done with the processing of the current level, I change my pointer of the next level to the previous level.
Right.
Yeah. So it's important to know both these techniques. Maybe I'll send the code maybe later on so that you guys read it, understand it. And this is like the starting point for BFS. So if you want, I have like a bunch of questions to practice this. So maybe I'll go with another question. Okay, so let's see this one. 102. So guys, any problem with the first 2 questions? I took a harder problem in BFS.
No, I guess it's good.
Okay, so this is the most basic question in BFS. Given the root of a binary tree, return the level order transversal of its nodes values. So basically here, right, you're just returning 3, 9, 20, 15, 7. This is level order traversal. Same thing as BFS.
It's the same. Yeah. Okay.
Exactly. So if you know how to code BFS, this is very simple. So in this, as I'm going through each level, I'm just appending to my result. You want me to code this? Both these styles?
I guess that's okay. I guess I
Yeah, no
think
need.
yeah.
Right. So wait. So there was one more question. So this is level order, right? So let's see a different question here.
Why would this level order be categorized as medium though? Isn't
Depends. I don't know. I mean, if someone has not done this before, they will create a hash
mean,
map. They'll
The
put in all.
pre, in order, and post order are all medium questions.
oh okay.
When I in my first onsite, not onsite, like after my first year, after when I was doing my masters, Amazon gave me level order traversal in my phone interview, and I had never done like lead code before, so I actually gave them the hash map solution. Which is like, and I got rejected. I was so happy I got accepted, but I got rejected. Later on, I figured out what was the issue. That I shouldn't be. What I was doing, I was creating a hash map of levels, and each level I was appending my node to that. Instead
Actually,
of
yeah, go ahead.
no, go. I'm done.
I got also questions to Amazon on site, but it was a level order, but bottom up approach. They asked me on
Right.
site.
I think you add 50, this one, right? 15, 7, 9,
Yeah.
20, and 3.
Yeah.
Hmm.
They asked me to code it up.
I'll
bottom
add
up.
3 first, 9, 20, 15, 7, and then I'll reverse and I'll return back.
Yeah.
So is everyone clear with how to do this?
Now, in
These are-
this case, you're suggesting as we do BFS, we are simply going to reverse the order in the end. That's what.
Yes. Like
Okay.
I want to keep my solution very simple, a coding way. I just do a BFS, I append 3, 9, 20, 15, 7, and I just reverse and return back.
Yeah.
So Tobias, when inserting each level, right, you like give the position as 0 so that they will automatically get reversed, like one line instead of explicitly writing a reverse function.
So say again, what did you say? Return 0. What?
No, when you're adding the level, each level's values, right, you put it at the 0th index.
But then you're inserting, right? Inserting to an array.
Yeah.
That is bad, right? That is itself O of n. You shouldn't be inserting to an you shouldn't be inserting to the 0th
Okay,
index.
instead it's better, yeah, the time complexity wise, it's better we
Return -1, like
do
return
reverse
everywhere.
at the end. Yeah, instead of like for every level pushing all
Yeah,
the
never. I have seen you even before earlier. Also, you said the same thing. We'll insert at the front. Never do that.
Okay.
It's always better to use DQ in Python, which is we talked about, right? DQ, you
Yeah,
doubly
yeah.
linked list using like using linked list. DQ using double linked list. That is the
Just
best
the
way.
linked list is sufficient, and then
Yes.
you can add them in the reverse order to
Yeah.
the final result.
Yes. But here, if we are coding, we use it array, and it's better if you return the reverse at the end, right? So
So maybe for later, but I'm curious. Yeah, I'm not sure I understood why that was not a good idea.
no, you never insert. So what Sue was saying is, let's say you have 1, 2, 3, and 4, right? What she is saying, if to insert 5, she said she'll insert at the 0th index. So it will become 5, 1, 2, 3, 4. What I'm saying is never insert at the 0th index. Always insert at the end.
Why not?
I'm just saying that inserting anything at the front is a bad idea.
No, that's because of the time complexity, Tobias. Like
Because you'll have to, let's say this has a lot of spaces. It's like you'll have to shift 4-year, 3-year, 2-year, 1-year, and then make space for. You have to make space and then put your 5 years.
But like in Java, for example, if it's a linked list, it's just O of 1, right?
Yeah,
yeah,
linked
if
list,
you
but
use a linked list, yes, it is just order of
yeah,
one.
but when you're solving BFS, you're actually like solving this using arrays, right?
So
we
this
can use a
part of the solution you're talking about just adding to the result list, right?
Yeah, at the end, and you return the reverse.
Yeah. So since you're maintaining a result list, I think it's fine.
Right.
So if this 5, 1, 2, 3, 4 is your result list that you're going to print at the end, right?
Mm-hmm.
So as you're going down level order, you're simply adding to this list. And then if you add it to the 0th location, 0th position, right? In the end, yeah, I don't see what is the issue because this is just your result list.
So you start with 1.
It's not a single list, Tobias. It's a list of integers. You are pushing each list to that list of
See,
lists.
okay, so Tobias, so let's say initially you start with 4. Your result is 4. Let's say
Yeah.
you want to append 3 at the first. You do this 3 and 4.
Okay.
Then you do 2 and 3. That is what you're saying, right? I mean, if
Yes.
this is your result, and then
Yes,
you
yes.
do 1, 2, 3, 4.
Yeah.
Yeah, appending to your result, that is itself going to take a lot of time. Let's say if you have 1 million elements in your result, and if you have to add one more at the front, you'll have to push all the elements to the end and append
Okay,
it.
okay. I'm still stuck with the thought that, hey, if it's a linked list, pushing to the front is a no-brainer, right?
No, that is I'm talking about array, because when you are coding,
Okay.
we actually use arrays, right? So
Okay,
this one.
if you're using arrays, I mean,
Ankur,
do
actually, he's right. I just tested it out. Like I changed from array list to just using a linked list, and it performed much better than
No,
using.
I mean, see, lead code never go with time complexity. Lead code, that what they do is, are you using premium or non-premium? So it never see that. I mean, basically, if you're inserting at the front, that is bad.
No,
Don't
it is not if you are using a linked list in order.
But you're not using a linked list.
The question is using an array. What's the best way to handle it? Forget
The
linked
way
list,
to
okay?
say
No,
that
no,
it's
no, no, no. Really,
that-
honestly, that's why I'm trying to understand,
Yeah.
because since I come from a Java domain and
Yeah, but I don't come from Java, so I don't have a natural implementation of a linked
Okay,
list.
okay. See this one.
Hey, Devin, that's fine. We're
See
just
this one.
because Ankur presented the idea that there is a performance there is a complexity because of the shift array, and Sue suggested earlier, and I'm as a linked list solution. So I'm trying to understand what's the point he's trying to make.
No. So see here. So you can see Slack, right? This Sue solution.
Mm-hmm.
So she used a linked list for Q.
No, not that one. The
Then?
final result. This is. I mean, this is not required to the final result.
Depending on
Where I am pushing at 0. At
No, this
index
is
0.
wrong. This is, you should not be doing
No,
this. I
no,
mean,
that's what it is not wrong if you're using a linked list. It is still order of n. Only if you're using array list, then it is order of n complexity
yes,
for
yes,
adding.
yes,
But
yes.
Yeah,
see, I see,
but,
earlier
but what's the
I
answer going to
looked at-
look like with an array? Because I don't have a linked list.
Yeah, so
It's
for
okay.
array
We
makes
are
sense.
talking the same thing.
Don't do this for an array. Absolutely not.
Yeah,
Yes,
don't
yes.
do this for an array, but because in Java there is a provision of using linked list, you can still push it at index 0
Yes, yes,
and
that is fine.
better time complexity.
For linked list, it's fine. So okay, so I'll just I'll just write it down for linked list, or basically for doubly linked list, or for linked list, appending to the front is fine. To the front is O of 1.
Are you sharing your scribble?
Yeah, and for array, inserting at the 0th index is O of n. Fine, that's all. If you're using Python, Ruby, Java, it depends what you're using, but eventually it'll all come down to this. Right? Everyone agree? Still no.
Yes, Ankur.
Yeah,
Okay, fine.
Yes.
because you have to
So
shift the entire list.
yes, right. And so let's go to a different question. Maybe the point I wanted to say was vertical order. So I have a bunch of questions. I'll not be covering them, or do you want me to have I'll just show you my notes.
It's okay if we don't cover everything.
I'm not covering
but-
everything, but
Yeah, but at least definitely compile a list so we can do homework or go through it.
I'm not sure who is doing what. The thing is, even if I
Don't worry about who's doing what. See, I'm telling from my experience too. It's like
Okay, I just sent.
all the ones that you've done before. I'm still catching up to that. I've not done, but it's still helpful to know that it's there, and I can go and start doing
So
practicing.
I just
Yeah.
posted on the general channel.
Thank you.
All these
Yeah,
are
thank you,
just
Ankur.
BFS.
Yeah, I guess it's good to have that homework question. So
But-
even little lacking behind, still catching up with that.
But the thing is, so now it's like you didn't done BFS. What I wanted to do was so this is like the whole list of BFS and tree combined. What I wanted to do was after a week, I wanted to send if I wanted to send a BFS question, it's like it's already covered. There's nothing else to now send. Like if you do this, BFS is done. Right now, there's no other homework to give for BFS now. What's the point? These are all the questions in BFS for trees. But it's good for practicing, I think. Maybe I'll just repeat a question maybe after a week. And there are some tough questions which I don't think you guys will be able to do. For example, vertical order. And yes. So remember we did vertical order long before?
Yes, yes. After discussing with you, I coded it, Ankur.
Yeah, but it was,
Last
yeah, I mean, it's a very frequently asked question. I was asked in, I think, Facebook. Most of the questions, I mean, yeah, you're asked in Facebook and mostly you'll get that question. So it was a very good question as well. So we will not do it today, but maybe later on, okay? And so now, so BFS breadth first search is done, right? But now let's go to 2D matrices.
There was one more question which you did along with vertical order traversal, which used the same concept of.
Yeah, it was, wait, let me see what that was. Was it breadth first search? Vertical order?
Breadth first search.
And I think it was column by column traversal.
Yes, that's right. That was column by column traversal.
Let me see if it's there.
How
That was a 3 or 4 question. You took it back in times. That was column by column.
How
Yeah, I
is
did.
column traversal different from vertical order traversal?
Let me just see what this is asking.
Yeah.
No. The question I asked you was, sorry.
So you discussed one
No.
question.
My
which-
question, the question I gave you, it was something like a sorted thing question. Right? Like if you had 3 like this, it was something. I mean, I'll have to find out what that question was. I forgot. Maybe I'll have to wait. Let me see that first. Okay. I have to number of islands. Vertical order traverse. Is it this vertical order? No, it's the
vertical order
same thing,
traversal.
right?
There are 2 questions, but before these 2 questions, you gave a different question.
But same column wise. I mean, it was also doing something column,
It
right?
was also giving some assigning these values like this, like going to the left, going to the right. Based on that, you gave these questions as homework, vertical order traversal.
Did anyone? Okay. Yeah, maybe I'll cover that again. Maybe. Bottom left. It's not. I'll have to search. Yeah, but I think first, if you guys does do the basic of BFS first, understand how it is done, remember how the technique to solve both the questions, then we'll go into how to do vertical order traversal or column by column traversal, right? So that is why I don't want to take that right now. And now I wanted to go into 2D BFS and 2D matrices. But before that, I wanted to show one more thing. You guys listening, right? Hearing, right?
Yeah.
Okay.
Yes.
So one of the things I want to show is, I mean, if you know this technique, you'll be able to solve any 2D matrix BFS. And you just all you have to do is just look at the various type of questions on LeetCode. On that, I'll send that list also. But once you do that list, it's like your BFS, that fear of will be gone, right? So one thing I want to share is, let's say you have 1, 2, 3. Let's say this is 4, 5, 6, and 7. Right? So what will you do in level order traversal? We first process this one, then we process this, then we process this, right? Right? And at each level, what we did is we only went one level down, right?
Okay.
So it's basically that's all. I mean, this is what you have to remember, that if you have a bunch of nodes, and you have to move everyone by one step ahead, it's BF. Like if you do a BFS with all these 2 nodes in your queue, you will be able to take all of them one step ahead. Does that make sense? Should I repeat again?
No.
Okay.
Yeah.
So let's say you have, right now, let's say you have 1, right? You do a BFS, you go to 2 and 3, right?
Yes.
Now you do a BFS, you go one more level down, 4, 5, 6, and 7, right? And if you do one more BFS here, you go one more level down, right? So basically, when you're doing a BFS on a particular level, you are going one step ahead, like one step down, or one step forward, and you're taking all the nodes and you're moving all the nodes forward by one step, right? So 2 move by one step, 3 also move down by one step, right? Now, if you do a BFS on these one by putting in the queue, these all will move into the one step down. So that is what BFS does. But if you do DFS, you cannot, you don't do that, right? Okay. Just remember that point. Okay. Now, let's try to solve this question. This is also like a companies. Yeah. So just see this. How many times it has been asked? Okay. You guys reading this question?
Yeah.
Anyone done this
Yes,
before?
Ankur.
No.
No.
Okay, good. So you?
I did it, Ankur.
Okay. Then let's go maybe to this question.
Three
Then.
value set.
Okay, okay, sorry. This one.
There's an empty down orange. Orange.
So base, okay.
Any
The-
orange
these are
that is
your-
4 directionally adjacent to a rotten orange becomes rotten. So any orange that is next to a rotten orange becomes rotten.
Yes. So basically, if you, I mean, you have your orange here, and this first step, so first minute, right? It is going to pollute, make these two like bad, right? Rot. That it is going to rot these two oranges. Second minute, this will actually rot this one, the down one,
Right.
right? And the third step, this will rot the next one, and fourth, it will rot this one. Understood?
Yeah.
And it's always left, right, upper, left.
Down.
It's not diagonally.
Right.
And you have to return the minimum number of minutes that must elapse until no cell has a fresh orange.
Okay.
Everyone understood the question?
Oh, that's a cute question. I like that question.
Yes. I wanted, like, that is what BFS first. And if you understand that, like, you'll be able to do most of the questions on this one. On this step.
It's a direct
No,
BFS
wait,
question.
wait. I know, wait. So let others understand the question first. Like, what is happening? How it is happening? Arias, Tobias, what else is here? AK is Avinash, right? Avinash? And Anil. Okay, he's just listening. Okay. So Arya and Tobias, clear with this question? What is saying?
Yeah, yeah.
Arya?
I'm still not getting understand that what is minimum number of minutes that must elapse.
Okay. So look at the first picture, right?
Okay.
We have one
Okay.
rotten orange in the upper left corner. Okay.
Yes.
After 1 minute, any oranges that are next to an orange that's rotten, either up, down, left, or right, also turn rotten. Okay.
Okay.
So if we look at minute 2, we see the orange to the right and the orange to the bottom have become rotten. Right.
Okay.
So you
So now we do another loop. We have the third minute. So now we apply the same rule. Any orange that is next to an orange that is rotten also becomes rotten. So you look
Okay.
at minute 3, that orange to the right becomes rotten, that orange in the second column becomes rotten, right?
I see.
So now
So
you go to minute 4, that one orange becomes rotten, you go to minute 5. So,
If we, oh, I see. So it's basically it's reached to the end of the
until
array.
all the oranges are rotten.
yes.
rotten. I see. Got
And
it.
if you cannot
has to-
return, yeah, and if none of the, I mean, if at the end you have some oranges which are not rot, you return -1.
Okay. So basically we have to traverse. Yeah. So that's what. Okay. Got it.
So this is
Uncle,
the question.
your voice keeps on breaking up.
Oh, I think it's because maybe I'll give me 2 minutes. I'll shift to I'll shift to the my head. Okay.
Yeah.
You guys can hear me now?
Yeah,
You guys can hear me?
yeah, better.
Hello?
Yeah, we can
So-
hear you.
Hello?
I don't think he can hear us.
Hello? हेलो ये आवाज क्यों नहीं आ रही है यार
Hello.
Hello.
Yeah, yeah. Now I have to remove my headphone. You guys can hear me?
Yeah.
Okay. Yeah.
Yes, we can hear you.
Okay. Yeah. So the question is clear.
Yes.
So yeah. So Devin, you don't try. I think let Tobias or Arya try it.
Okay.
Did someone write something? Yeah, Tobias.
All right. So in a sense, I understand that, because I can do a breadth first search, I can start applying the breadth first search till I think I've reached till I've reached a leaf node. But now where I'm a bit stuck is, okay, how do I decide what is the root? Is it always
You're
going to
not
be?
trying to find the root. You're trying to find the number of minutes. You're not trying to
Sure.
reach all the. I mean, here you don't have to reach all the. You're not trying to reach all the oranges, right?
Right.
not
So
a
I
road.
can potentially just find any one. Could I find any one rotten orange? So yes, I don't have to find. I guess I don't have to find everything, but I'm thinking. This is what I was thinking. Like every minute means I'm going to apply a breadth first search from a starting point, right? Till I think I've reached the end, and then I just need to see. Oh, I see. Okay, so I can just need. Yeah, my indecision was around which would, if I just randomly pick, or I have to pick every
No, it
rotten
looks
node.
like your input grid had one rotten orange.
The input
Oh,
grid is one orange.
The two
Right.
represent a rotten orange, right? The
Right, so-
clarification question I have is there only one rotten orange, or can you have more than one rotten orange?
You can have multiple, right?
You can have multiple rotten oranges in the
Yeah,
beginning.
if you have, let's
in
say,
in your initial grid.
yes, if you start from minute one, let's say this one is your
No.
Put
So
it right.
the question is, at minute 0, is there more than one rotten orange?
There can be. Why not?
Okay.
How
Okay,
how
so
will
you can
change
start.
your-
You can start off with more than one rotten orange.
Yeah, I mean that will basically become your minute one. I mean here your minute one will become your minute 0 if there are multiple oranges which are rotten.
Okay, that makes sense.
All right, so then that way I would treat that. Okay, first I would try to find all the rotten oranges and try to treat that as my root, and apply BFS to see.
But why BFS?
Because it's neighbors, right? The only question is 4 neighbors. As long as I can use, so it doesn't have to be. As long as I find the 4 neighbors for each iteration, right? Each child, and then traverse each child. So that's why I said BFS.
So Sue, you did this question, right, Sue?
Yes, Ankur.
So do you want to explain the intuition, if you can? Like even
Yeah.
Have a good one, Arya.
Yeah, the intuition is like, because we have seen 3 questions, I think it is natural for us to think that we will start from one single point, which is the root. But here it is, the starting point is not one place, but it is from all the initial orange positions. So
Well, I think the first question I do have is before we get into that part. When we initially set up this grid, should we check to see if any orange has no neighbors? If that's the case, then we return -1, right?
that you, instead of doing a check like that, I mean that your code will automatically handle it.
How will the code automatically handle it? Because you're never gonna find it.
Yeah, you will do this like you
Like,
will
what's your
you will basically run a timer. You start like in the first minute is when like all the immediate neighbors
No, no,
like
I think what Deven is saying is if there are no rotten oranges, you return -1. Right, Deven?
Meaning, if
Yeah,
there's
that-
any orange that does not have a neighbor, right, it can never become rotten.
Why
Oh,
do you
you
want to do
mean-
that? I mean, that will eventually happen, right? I mean, if I mean, when you start your algorithm, you start, and if you finish your BFS and you still have if you still have fresh oranges, you return -1.
right, right.
Yeah,
That's the
okay.
same thing what you're saying.
Yeah, that's
Yeah.
what I'm trying to say. Like, don't bother about doing it before itself. Like your code, you will
We'll eventually do it.
not do it, yeah, will automatically do it, and at the end you will have this check if any fresh orange is remaining, even after
You
making
return.
all the neighbors rotten each minute, then you return minus, and otherwise you return your minute counter that you are running.
Okay.
Okay,
So
and I
in-
mean for -1, right? You just go. I mean, one way to return -1 early is if there are no rotten oranges in the array, return -1, and if there are some fresh oranges also. If fresh orange is present and no rotten orange is present, return -1. Right?
so that you will, because you will do a fresh orange check at the end anyways, and then you start with you start your queue with putting all your given rotten
Wait.
orange.
No. So the thing is, I wanted to explain what is happening here. Let's not go into queue right now. Okay?
Yeah,
Just,
not good
just,
with you, but yeah, what I meant to say is you will start with not just one point, but all the points where you have your rotten oranges.
yes. So Tobias, did you get any idea here what is happening? Okay, you know it. There is we have to apply BFS. So the point.
No. Actually, if you heard, that's what I did start off, right? I did say that every iteration you want to first find out when you start off with figuring out who are the rotten oranges, right? And in my mind, every rotten orange that I've not seen, I would apply BFS considering that as a root. And that would be my minute
hold
zero.
Hold on. I know. I mean, right now, everything that is going in the mind is BFS, but
Yeah.
something else I want to show you. Huh?
Right. So even if it was not BFS, for this case, it just needs every neighbor, right? Even if I did, I just need one level every neighbor, and that to me is
Yes.
BFS.
Exactly. One level every neighbor. That is the point. I mean, after every second, all you're doing is you're going one level down. So when I was trying to explain this one, each level, if you have these two as rotten oranges, after 1 second, these are going to be rotten oranges.
Yeah.
Right. That is what I was trying to say. Like if you want to go one step, and another thing is one more keyword for you to know is minimum number of minutes. When it says, directly think about BFS. Anything minimum, so BFS, right? I mean, it's a known thing that if you need to reach a point earliest, you use BFS.
Oh, like shortest path kind of thing.
Yes. I mean, and if all are like same length, right, or same weight, you use BFS. So that's one of the first thing you have to notice, right? And here also, since you have to traverse one level down, and you have to traverse, you have to take all the nodes to get like this one. You're traversing 2 and 3 together, one level down. That is what, again, 1 minute, which is what we are doing here. Is it clear to everyone?
Yeah.
Okay. So and I mean, I assume now should we? Okay, wait. So what do we do now? Should we code this or should I go into the next question?
I think.
Wait, I do have a question here though. So at every level, right, or at every minute, we are going to check is there any more fresh oranges left, right?
Mm-hmm.
And so that's just going to be an O of n. Is that how we're going to do it? We're going to go through
Say again.
What is the complexity to find out if we are done with?
I mean, it's
every
still
minute.
nm. I mean, if you have number of rows is n, number of columns is m, its space and time is n into m.
So can we code it?
Can we code it? Okay. Sure. So then you tell me how to code this up.
So Ankur, I
Yeah.
don't know whether you discussed this.
Mhm.
So in this, there is a possibility that we might have non-rotten oranges, right? We might
Yeah.
have fresh oranges, which we cannot even reach by doing BFS.
Mhm.
There could be a scenario, right?
Yes.
Yeah.
After your BFS
Still-
is done, your if there are oranges present, fresh, you return -1.
Okay, so you are, I mean, so
Uh,
I mean, I was not a part of initial conversation, so people are aware that
Yeah.
even after doing BFS, we have to iterate over the matrix again, right?
Right.
Okay, thanks. Sorry. Yeah, I just wanted to bring this point. Yeah.
Yeah. So before I code this up, I want to show another question. Then we'll come back to this one.
Okay.
Okay. This one. We'll go back into rotten oranges, but first try to read this one, 1162. Got it?
Hold on.
So basically here, this one, right? This distance, this is nothing but your whatever we say, right? Left, right, up and down. That distance. It's not that.
Oh,
after
your
the-
x distance plus your y distance. Okay.
Yes, basically, if you're at this 0, the distance from this one is this. I
Right.
mean this.
It's one
This-
one
yes.
horizontal, one vertical. So that's 2.
Yes.
Right. For all the other zeros, it's 1.
So now, is the question clear to everyone? So have you done this one before?
No, Ankur, I have not done this.
Awesome. So Virus, what are you thinking?
Oh yeah, I'm just I'm still digesting.
Don't throw hammer at the nail. That'll go.
Yeah, sure.
So what are people thinking? Want to know. Don't let your interviewer sit idle.
I'm thinking it is 8 direction possible,
For,
not
for each 0, you need to calculate the distance from all the ones. So you need to keep track of all the ones, for example.
So it's like you're doing BFS from every 0.
Yeah.
Okay. Yeah.
But you
that's
can
fine.
run into a situation where you have a 0 that's totally surrounded by 1s. So
But that's fine, right? That is the distance is 0. I mean,
the
the
distance is
will
1.
be
It's
like
still
1.
1.
Yeah, 1. But you need to find the
The
nearest
0
cell.
that has the max distance.
Yes. So in the example 2, it's the rightmost.
Right.
And here it is the middle one.
Right.
Because this,
It's equally distant from all of them.
yes, I mean the distance is 2, and this 0,
Is
I mean
1.
its distance is 1 from its nearest land cell. Exactly. So you want a number 0 which is as far as possible from a 1, right?
Right.
So yeah, I just give the hint.
If no land or water exists to return -1.
So one of the ways is that the way Deven said, you do a BFS from every zero, calculate the distance from a particular zero to all the ones, and then that no. If you do a BFS from zero, what will happen? You'll get I mean, from a particular zero, you reach a one, and that is your distance, right? So you do a BFS from every zero, you eventually you touch every one, and you return the one that has the maximum distance, right?
Right.
Everyone understood this one? What we are actually trying to do?
Yeah.
So why is Arya?
This one will be harder to code than the other one, though.
No, we have not. We have not. This is a brute force solution.
Is it the one with a maximum depth? That's what we are looking for. I'm not sure if that.
We're calculating distance. I don't think we're calculating depth.
In the tree, if we visualize this as a binary as a tree, then are we looking for one with a maximum depth?
Yeah, as far as possible from a one.
From zero, yeah. Okay.
We need that zero whose closest one is as far as possible.
Yeah, there could be multiple ones, and all of the ones will have different depth from the zero that we chose.
Yes, and the first one that you get is that zero's depth, like distance from the one.
Okay. Got it.
And you need to return the maximum distance.
Ankur, I have a question. Like I was initially thinking if the neighbors are only the 4 directions or the 8 directions.
Four.
Yeah.
It's 8. Actually, it's 8. It's not 4.
No, it's actually
Right?
4 from the examples, but how do we infer that 4 or 8? Why did that Manhattan distance?
Manhattan
distance
means
eight.
you go left, you go up. That is distance 2.
Okay.
The distance is that way, but eventually you're going only left. You can only go up, right, and down. You cannot go down.
Oh, okay.
We did not mention that specifically. We have to infer that from that line where he said that it is Manhattan distance.
Yeah.
But it is not very clear to me reading that line. I thought like I can calculate from 0, 0 to 1, 1 as Manhattan distance.
No, if we do diagonally, that distance is still 1, actually.
Yes. No. If you don't go diagonally, the distance is Manhattan because it's 0, 0, 1, 1. The distance is 1 minus 0 plus 1 minus 0.
Okay, got it. Oh, that tells me that it is 4 directional traversal. Okay, clear now. Because he gave that plus.
Okay. So one hint is so first thing is one hint is so when Deven said you do a BFS from a 0, you calculate the BFS from every 0. You calculate the distance of that 0 from the first time it hits a 1. You note it down, and you return the one with the 0 which has the most maximum, right? Okay. So that is making you do a BFS from every 0. Reverse it and do a BFS from a 1 instead. This is a concept which you'll use in everywhere. If you're doing if you're doing a BFS from a single number and you're figuring out you have to do a BFS from everywhere, there's no other way. Now try thinking in your mind, what if I did a DFS from a 1 instead? Now think in that terms. What will happen in that?
Yeah, makes sense.
I mean, it's just that you get a question. It's like you have to think, what if I do this? What if I do that?
I think we can eliminate the zeros that we see in the. I mean, as we traverse the tree, we can eliminate all the zeros that we see in the beginning.
The one question I have is for every 0 we reach, we have to calculate the Manhattan distance from every single one, right? So that means in the first example, for each of those zeros, we're calculating 4 Manhattan distances.
5.
Okay. Right?
There are 5 zeros, right?
Yeah. Okay. Give me a second.
Yeah. Okay. So Arya, are you thinking something? I lost.
Is it okay to? Yeah, go ahead. Sorry to interrupt.
Was he saying something?
No, I have a question.
Go ahead.
Yeah, is it okay to turn these ones into some negative values like -1 so that as we populate the neighbors, right? We populate the the breadth first search, like the distance, so that we know if that is a one which has come from a distance or
5 minutes. Okay.
is it okay to make those ones as minus ones initially and then do our BFS from all those minus ones and fill up the neighbors with
land?
the distance? Like,
So why -1? Start from 1, no? I mean, you're changing 1 to -1.
no, with changing that, I know which cells to skip, right? Because see, I will populate the distance here on the neighbor cells like.
Okay, one more hint. This
Yeah.
is nothing now. This is nothing but your routing oranges question. Now think in that terms.
I think we can. I think
I
from
see, got it. Yeah.
the initial question that you asked, like if you traverse from, like if we consider 1 as root and do a breadth first search, what happens? That was your question, and I think like we can find we can for each and every 0 that we see, we can assign the depth, assign the distance for that 0 from this one. Is that correct? As we traverse, let's say if we
so my question is why so this is the point I'm trying to make is, see, this is a 2D array. This is not a tree, right? So when we do a tree, we start BFS from a single root, right?
Yeah.
But this is a 2D array. Why are you doing a BFS only from a single one? There's a way to do a BFS on all the ones at the same time. Do the BFS from every single one that you're getting. Start doing the BFS, and at the last step, you're going to get that 0, which is as far as possible.
Yeah. Got it.
Right. So wait, I'll just show this 1 second. I'll just draw it on the matrix on my whiteboard. 1 0 1 0 0 0 1.
Can you show your board?
Yeah, I was just noting down. So this is your matrix, right? So first step, if you do a BFS, what happens from everyone? Otherwise,
yeah, at level 1 we'll have 4 zeros, I think.
You'll become this one, this one, this one, and this one, right? Same as rotten oranges.
Yeah.
Right? So you know that is level 1. First step, you made this all as 1. Right? Now what is going to happen? Now this one will make other zeros as 1. At second level, this became 1. Right? Now there are no zeros left. So the moment the last 0 becomes a 1, that is your answer. That is your level.
Yeah.
Exactly.
I'm sorry, I didn't follow. So you started off with all the ones, right?
Yes. No. I started from what the one that you're already given.
No, we start with all the ones, right, Ankur?
Yeah. Basically all the ones in the sense, like all the 4 ones. This one, this.
Ankur, I think if you draw it as a tree, right, it will be easy to visualize. So the 4 ones will be at the top level, and then there will be 4 zeros at the second level, and 1 0 will be.
No, every one will have 2 zeros, right?
No, it's more of a graph, right? The same 0 will be there. So
no. So this one has two nodes, right? This one and this one.
Yeah, that's correct. But
yeah.
If we draw like 8 zeros, it will be confusing, right? We should.
It's not 8 zeros. Yeah, I mean 1 0 is being shared between 2 ones.
Yeah, between the 2. Yeah, that's correct. Yeah.
Right, and there is some 0 which is connected to all these ones.
So yeah, only yes,
Right?
that's it. Yeah. So there is level 1 is there. Level 2 is there. The 0 at level 2 is.
This is 2.
Yeah.
So as soon as you reach this one, this is your last level, right? So you return 2.
Yep.
Because you don't have any more zeros left. Got it, Tobias?
Still.
Don't think about how to code this, but this is how you think. So coding is the next part, but the first most important part of the interview question will be to figure out what to do. If you can't even figure out what to do, you'll be lost. I mean, I gave Facebook phone interview, I think 3 months back. I was asked something like this. I couldn't even figure out what to do.
In phone interview, you were asked this, Ankur?
Yes.
Oh.
Not this, but I not exactly this, but a different question, something of a minimum, something. Maybe it was, I think, this orange question. Not an oranges.
Okay.
I knew it was a BFS, but I couldn't. I didn't know about this technique about BFS and how to do the BFS, how to think. So I started using DFS. It was even the wrong thing, but that is what I'm trying to teach today. That when you get something which says earliest, and which also says that, which also telling you that if you do a BFS from every 0, worst complexity, you reverse it on its head, do a from 1, start a BFS from every 1 at the same time. When you reach 0, you get the answer. So it's very important to know these things. Tobias, is this clear?
So what did you mean when you get to 0? So you're starting from each one, right?
Mm-hmm.
You find that all the neighbors, you're finding the neighboring zeros.
So let's say
that's the first level.
Let's say initially in your let's say you have a set, right? And you're storing all the indices of the zeros, right? 0, 1, 1, 0, and everything, right? Let's say 1, 1, right?
Okay. And the set is the neighboring zeros, right? For each.
All the zeros present in the matrix.
Oh, okay.
As soon as your set is 0, and there's nothing else to process. I mean, as soon as your set is 0, you know that the last level is your index. Because the 0 you saw at the...
Oh, okay. Okay.
Because there might be still ones left in your queue. Right?
Yeah.
I mean, basically what you're... Right? I mean, you're trying to convert every 0 into a 1, basically. You're trying to spread your virus, and it's consuming everyone at level 1. And eventually, at the last step, you get the no island, which is the furthest. And that is your answer.
I'm back. Sorry about that.
You missed something important there.
Can you go over it one more time if you don't mind?
So when did you leave? I'll try to cover from there.
I don't have a deadline tonight, so.
No. When did you leave? I mean, what was the last time you?
Oh, I left right before we started this whiteboard.
Okay, so basically you said, right, we do a BFS from every 0.
Right, and you were saying just do it from a 1.
Yes, and then Avinash mentioned about this. So what I said is you start a BFS from every single one at the same time.
Right.
What will happen? You convert this into a 1, this into a 1, this into 1, and this into 1, like rotten oranges. Right?
Oh, okay.
Now what happens? Then you get this one at the second step.
Right.
So that's the answer. I mean, the moment you visit the last 0, that is going to be at the furthest.
Oh, okay.
So exactly that's what I'm saying. So then Avinash told me, or AK told me, so let's draw this tree. So you have this ones, sorry, this graph. You're starting from 1. They have zeros, right, as neighbors.
Right.
So level 1, only these, you cover these ones, these all becomes 1s.
Right.
Or you point them. And then level 2, the furthest 0 is what you reach.
Okay, and oh, that's a neat way of doing it.
Yes, so this is a very important technique you have to remember when to use BFS and how to use BFS and how do you even think about using the BFS. So basically this question, right? This says the nearest land cell that is maximized. So see here, you have nearest land cell. Maximized means the first time as soon as you get a 0, I mean the last moment you get the 0 is the nearest land cell. You return that. I mean you have to understand that.
Right. So as soon as you have no more zeros.
Yes. Exactly. And as soon as, yeah, exactly. As soon as you don't get a 0 is the nearest land cell maximization.
Okay.
Clear to everyone this one? I'll maybe you guys can code and maybe tomorrow I'll send the code.
Can you post both of these questions just in the orange question? So. Thank you.
And these two questions are really very important for your interviews. I mean, so make sure that I mean, because this I was trying to do them yesterday, and I couldn't figure out what to do. So it's like it's a sort of a technique that you have to practice and get used to it.
Okay.
Right? Okay. I'm not giving you the code yet.
Yeah, just to post the problems. I'll take a
there
look
was
at them
one more
tomorrow.
question that I wanted to show.
Ankur,
Yeah.
so these questions that you are doing today, are you posting it somewhere like general channel or somewhere?
General.
You're posting it over there, right?
Yes.
Yeah, they're both. I see them both in general. Oh, there's a whole lot of
Because
questions in general.
because I did see like you posted a bunch of homework problems.
Yeah, that was for basics of BFS.
Okay,
Now I wanted
So
to
that-
go into one level into 2D arrays.
got it. So you're going to post the next level of questions as well on general channel, right?
Yeah, he did. They're already there. They're dropping.
Yeah, I'm not going to go into DP yet. DP maybe next week.
Yeah, I didn't even say DP.
I thought okay, yeah. So that's all. I mean, and yeah.
Thanks, Devan. I was just driving, so I couldn't see everything, like chat and Zoom.
Yeah. Anyhow, I think I'm recording. So
Oh, awesome.
yeah. And this is the another question: shortest distance from all building. So see this one, guys. So you guys already know there's going to be a BFS, but the thing is how like what BFS do we do? Let's read this one. So you still here?
Yes, Ankur.
Oh, okay. Because you usually leave at 6:30, right?
Yeah, my kid has been pulling me. I'm just stopping him.
No, anyhow, I'm recording. If you want, you can leave.
Yeah, I usually get lazy and not watch the recording. Instead, I can
Those
passively
recordings,
listen.
even I wouldn't watch. They're so boring, so slow. So just read this question. And this is also saying Manhattan distance. So you guys know what it's saying. Understood the question? Even
Yeah, I'm reading through it. It's a little tricky.
don't yet solve the question, but just understand what it's saying.
No, I haven't even tried solving. I'm still reading through it. It's all the building.
So building.
So you want to minimize the travel distance between wherever you build and all the buildings.
Yes. So basically, yeah. I mean, I want to build a house so that the distance to all the ones is minimized. To all the ones is minimized. This is not similar to the earlier question we saw. Like as far from land as possible. This is from all the ones it has to be minimum. So this, if you put a 0 here, this is 3. Go down 1, it's 1. The next one, it's 3. So 3 plus 3 plus 1. So it's 7.
Oh, the sum has to be minimum. The
Yes.
total distance sum has to be minimum. Got it now.
Yeah, even I'm trying to think of the answer because I didn't solve it. This is hard. Remember, it's hard. So what are you thinking? So, Devin, Avinash?
Yeah, I'm just reading the question. Yeah, I think we also looks like we need to use some kind of shortest path algorithm, Dijkstra's algorithm.
No, why Dijkstra? This is just same distance, right, from everyone, everywhere.
He's saying like we have to find a home which is having a shortest total distance, right?
Shortest total distance, yes. The extra you use when you have when the lengths are different, right? When the weight of the length, sorry, weight of the edges are different. Then you
Okay.
use
Here the
yeah,
edges are the same.
yes.
So you're not calculating the shortest possible path. You're calculating the point at which.
So Devin or Sue or Avinash, give the brutest solution that you can think of.
Brutest solution is for each zero, right? You calculate the minimum, the total travel distance to everyone.
Hmm.
And it's not the Manhattan distance because you can have something in between.
Say again.
For each zero, you calculate the distance to everyone and sum it up, right?
Hmm.
And it can't be in a Manhattan distance because you can have stuff in between, like another building or something else.
So when you calculate the distance, like for every zero, you calculate the minimum distance to everyone, and then you total them up.
Yes.
Right, but if you look at like the first row, right, that zero
Hmm.
right next to the
Two is
2.
there. Yeah, the minimum distance from like say cell 01 to the cell 00 is 1, but the minimum distance from cell 01 to 3,
You have to go around the 2,
Right.
yeah, you will go around the 2 and get the minimum distance
which is
for
1, 2,
all the
3, 4,
ones
5.
for a particular 0.
Yes. Right. So it's for the first the 0 which is on the first row. It is I think 1 plus 1, 2, 3, 4, 5. 1, 2, 3. So 5 plus 3 plus 1. 9.
Yeah, right.
Right.
Right. So you do I think BFS for every 0, right? Hmm.
Yeah.
Right? Is that right? You do a BFS
Yeah.
from every 0.
You can't. You have to basically. It's like that maid problem. You have to find the 1.
But what if you do a BFS from every single one at the same time, right? And as you're going, you keep updating the total distance to a particular 0. So let's say you start from the first one, those become
Right, but how do you deal with that 2 then? That makes it a little complicated.
no. So I mean, let's see. I'll just draw this on my this thing. We'll
2
just
is not the problem, but I think it has to be, even if you start from 1, updating you'll basically override the distance, I guess.
yeah. Let's see. Let's say we will try to solve this. Okay. So let's say one possible brute force is you do a BFS from every 0, right?
From
Right.
every
That was
0 to everyone.
yes. I mean exactly. So now we do the other way, right? So let's say we start from from every one and we do a BFS from every one together at the same time, right? And initially we can initialize all the zeros with I think distance infinity. So let's see what happens. So this will become distance 1, this will become 1, and this will become 1, right? And since these are two distance 1, this will become distance 2, right? And this distance will become 2 as well, but it will take the maximum of wait.
How do you stop from visiting it again?
Hmm?
How do you make sure you're only visiting it once from every 1?
Why one? Why once? Yeah, I mean from a single one you visit only once, but from every other one you can return it again, right? You can
Yeah.
visit it again.
So I think we have to create a 3D array, not a 2D array. And the third dimension is the number of ones. So you go from all the one.
So if a 0 is not, so initially we start everyone with infinity, right? Let's say we start everyone from infinity. So let's say as soon as this first one visits this one, we change it to like 1, right? We change this to 1, this to 1, this will become also 1, this will become 1. And anyhow, I mean, since we have already visited from this one, it's not going to visit it again anyhow, right? Because we are only going. Wait, we might.
If you're going left, down, up, right. If you're going left, down, up, right, you can go backward.
Yeah, you can. Yeah, for that one, if you've already visited, you don't visit it again. So
for each one, you need to keep track of the visited nodes. And then as soon as you hit a 0, you have a count. You for each one, as you're going through the best first search, you keep a counter as to what level it's on. Like when that way, when you go left or right, it's 1, and then the next time it's 2, right? So you add that to whatever is at the 0 you're at, but you don't want to. You just don't want to collide with the 2. That's the problem.
But if you start from a 1, this will go. You visit this one. But even if you're doing a BFS on every 0, or you're doing a BFS from 1, the time
you can do a BFS from 1 will be easier because you can keep track of the distance traveled, right? And update the 0 with the value traveled. It's a sum. So until the BFS for every single one hits out of bounds.
So I am thinking that we'll start a BFS from 0. From every 0, we do a BFS, right? So there'll be like so many BFSs from every 0. From every 0, as soon as you get a 1, you change the total distance if you were to build a house there, right? So if this 0 visits 1, and then this one, so it's going to be, and then this one, so this will be eventually updated to 8. If you do a BFS from this 0, this will eventually become like 1 and 3, 7, right?
Right.
That is easier, right? And if you do a BFS from this, you'll get 1, 2, 3, 1, and then you'll have to go 5. So this will become 8. So I think if you do a BFS from every 0, you'll be done, right? And from every 0, if you do a BFS, each 0 will have its own scene.
Right? Ankur?
Yeah.
I think the first idea that you mentioned, that where if we try to do BFS from all the ones together, so somehow if we keep track of the path in that tree to each of the zeros, when each of the zeros have whichever 0 reaches has a path from each of the ones first, that would be
no, but that is not going to be the total sum. That is going to be from a single one, right? If you
if we are using all the 3 ones as a
if you reach you'll reach here first, right? This one from this one, and similarly
so let's draw the tree. If we draw the tree, I think we'll be able to
wherever the one converged first had the least distance. Is that what you're trying to say?
Yeah. I'm trying to say that whichever.
Yeah. I see what you're getting at.
Whichever 0.
If you do a BFS from every 1, right?
Yeah.
As soon as the 0 has been visited by all the 1s, it had the least total distance.
Yes. That's what I.
And how? Okay. And how do you update the distance of this 0?
So basically, we have to somehow.
If you have an array, like just keep an array. There are 3 1s, right? So each 0 has 3 arrays, an array attached to it with 3 empty spaces, right? As soon as it's hit by one of those 1s, update one of those indexers.
Yeah.
That's a dirty way of doing it, right? But it's a cheap and easy way of doing it. Your space complexity in this problem is going to be ugly no matter what, right? So
no. So okay, so you're saying we create a hash distance, a distance of hash, and we keep updating. Let's say, and the key is the indices of every 0.
Yes.
As we are visiting them, we are changing the distance of that 0, and as we are getting the next one, we update based on its parent, right? And the 0 that we wait. And
the 0 that has no 1s left is the minimum one.
Sorry, which has no ones left.
Right. Rather than doing the hash where you're keeping track of all the zeros, right?
Hmm.
Each zero had a an array attached to it. Okay.
And when do you stop?
When that array is
And-
full.
Yeah, whenever any
Whenever the
zero-
array that length of the array equal to total
Wait.
number of ones.
So if you have a
Once, yes.
zero which is sitting somewhere at the end and which has two just next to it, let's say, right? Let's say this is your array, and you have, let's say, zero sitting here, filled by two here, two and two here,
That's never going to be visited
Yeah.
and if there's a
because you're
one
doing
here,
a BFS from all the ones.
okay, no. So what I'm saying is, let's say there is a zero here and there's a one, and there's a one here, right? And let's say all are zeros.
Yeah.
That zero in the corner is still never going to be visited.
Or let's say this
It's
is
totally surrounded.
okay. Let's say there's a zero here also, right? And so this is going to be the visitor at the end, right? At the last end.
No, we are not going to wait until we
Right. We're
visit
going to
all the
wait.
zeros.
We're going to stop as soon as we find a zero which had been visited by all the ones,
Yeah, that's it.
which in this case is that zero in the corner, the
Yeah.
opposite corner, surrounded by ones.
Oh my god.
So
Going to be-
think of it this way: each zero has an array attached to it, right? Okay.
Oh, okay. So you
As soon as that array is that zero is hit by a one, right?
are you saying that you count the total number of ones, and as soon as you find a zero that has been hit by everyone, you get the answer.
Yep.
And you keep updating distance also. Oh my god.
Yeah, you keep updating it.
Someone has to take the challenge of coding this up.
That's gonna take a few hours to code.
You don't have a few hours, 45 minutes.
I know, not now, but I'm saying I'm gonna sit down and focus on all three of these
Yeah.
problems tomorrow because
Yes.
this
Oh,
one's a
but
pretty
first do
important
this. I mean, I think maybe next week we'll take this question again. But once we have done all these basic questions first, like rotten orange, as far from land as possible, and the basic ones. Let's do this at the end, right? Because first, what we should be doing is practicing that we know how to at least do a simple BFS and know how to code up a single rotten orange solution before getting into this one. Otherwise, definitely we'll spend up like hours coding up this answer, right?
Okay.
I think that I mean we that is what even I want to do first. Like
I
first
think we
figure out
have
how
the answer. It's just putting it to code.
that is what going to take time. I think.
But are we all agreed that as soon as all the ones converge, we have the minimum zero?
I
But if you-
think, yes, Devin. Yeah, I think
We'll have to
I
come up
think
with
it's a
this.
solution, but I don't know if there are something that we have missed.
Otherwise, we have to calculate it for every single one, right? But
So
we
let's-
know that as soon as they converge, that means they've hit the minimum one because any other zero is just going to be longer.
Yeah.
So here, what is the answer? This every zero is the answer, right? No, this zero is going to be the answer, right? If all these are zeros, this zero is going to be the answer, right?
Yeah, that zero is going to be the answer.
Okay, and if you do a BFS, this will visit this first,
Right,
then this will visit this, this will visit this, this will visit this, this will visit this. Then what?
right.
Then who's going to visit zero then? If these all are visited, you start a BFS from here. Then what?
It goes up and visits to zero. The one above it goes up, down and visits to zero. Right,
No, wait. But this zero came in first. So this will start first, right? So this will visit this. Okay, it won't go anywhere. Then this zero will come out. Then this zero will come. Okay. This is going to be back in the queue. So then this will visit this.
right. And then the one beneath of it is the one above it. Right.
Then this will go up and visit this zero. But we have to
And-
make sure that a single zero, if it is visited, it can still go in the queue.
Oh, there's a bug with our solution.
Tell me, I didn't understand how.
You've come up with a situation where all the zeros are going to be visited by all the ones at the same time.
Hmm.
That 1 0 in the middle, we visited at exactly the same time as all the other zeros. But then if you keep track of the minimum distance, that's fine. All the others are going to have a greater distance.
How? I mean, how are you going to come to this zero, basically?
Okay, so in the first loop, they all go to the first row of zero, first column of zeros, right?
Hmm. So,
In
so,
the
so, so,
second
so,
loop,
so wait, so you have a queue, you have 5 ones here, right?
right?
And then you keep processing, then you remove this, you add a 0 here, remove this, you add a 0, you add 5 zeros here. Now
Right.
what, you get this 0, which is this 0.
Right, and that's going to
Right.
have 2 more zeros, right?
Yes, so this
To the
is
left and down.
going to add only 1 0.
That's going to add 2 zeros.
Why 2 0? This is has already been added, right?
That'll have to be added again because you're calculating a distance from that top one.
So why not? Why don't you go back from this 0 then? Because you're looking only for
Because
zeros.
you've already seen that one.
Yeah, and you've already seen this 0 also.
But that, how do you calculate the distance from that 0 to the first top one?
I think
yeah.
I think we have to somehow keep track of the visited from each one separately. So if you
Yeah, that's why I was saying use an array.
yeah.
See, I think everyone
So
is like,
each
no.
0 is going to have an array equal to the number of ones, right?
Yeah, that's correct. I think that's how.
As soon as, but we need to keep track of which ones have visited it. So that's the
Even
only.
let's just
Yeah.
leave this question. Let's focus on the ones that I gave us.
Yeah.
Let's practice those first because there's more probability of them coming instead of this one. And this is a hard problem, right? So
Yeah,
Ankur,
and there's no
have to
solution
leave.
listed either, which means people haven't really figured it out.
Yes,
so
because
much.
I think there are like multiple solutions. Even the author couldn't come up with the best answer, like optimized answer here. Maybe, yeah. So, no.
Ankur, I got to leave. Thank you.
Yeah, sure. Avinash, right? Yeah. So that's it, Devin. Or I had like few more, but I think this should be it, right?
Yeah, this is enough to the orange ones will take a bit of time to code. So I'm gonna code those tomorrow, and I'm gonna continue watching the I can't videos on binary trees. It's just that binary tree stuff is
Huh?
thick.
Say again.
That binary tree stuff is thick. Like my poor head.
Yes, but those are we are building blocks for doing BFS on 2D arrays, and 2D arrays are like so they are like the most loved topic by interviewers. 2D arrays. So make sure that you do these binary trees first, and then you come to this one because even I have to practice these.
Yeah.
I'm going to do all of these questions. Maybe today.
And then, do they ask bit manipulation a lot or not really?
So, say again.
Do they ask bitwise manipulation?
Not if you have like 10 years of experience, they won't ask you for sure. Like if someone has just graduated, they have more.
Yeah, because right now that stuff is just like, all right.
Yeah, don't even think about bit. I'm not even. Maybe I'll cover it at the end.
I want to look at binary trees, binary search trees, and then I want to do graphs.
No, but make sure that don't mess around here and there. But make sure that you get this concept first.
Yeah, this is
and
one.
2D arrays.
I want to look at these.
We'll go into graphs later, right? But first, all our building blocks should be like done first. Tags, queues is done, linked list is done, post order traversal is done, right?
Yeah, pre-order, post-order. The iterative solution for post-order is annoying.
Yeah, maybe we'll go. I mean, that's what I mean. I can't take that yet before people know. I mean, the
recursive solution for all of them is a joke. But the iterative solution for them is ugly.
Yeah, but for them, I mean, it is something that I'm working on so that I build that intuition. I don't want to be like, even I don't like memorizing the answer. I've done that before.
I don't like it either, but it's just it's weird. The iterative solutions for the order traversals are just weird.
Yes. So let me 1 second. Let me stop the recording. Right?
Okay.